everyone, today I'm going to demonstrate my EE212 project. As you can see here, I have designed a metronome using the KL25Z board and coding in C. A metronome is a device that produces sound beats at regular intervals, allowing musicians to practice at particular speeds. The speed range of my metronome ranges from 40 beats per minute to 200 beats per minute, which is actually the standard speed range for common metronomes. And as you can see, the sensitivity of the beats per minute of common metronomes can be quite low. For example, here it's 8 beats per minute. And in the metronome that I designed, this sensitivity is up to 1 beats per minute, so it's more sensitive. I adjust the speed of the metronome using this rotation encoder, which is actually the same thing as a potentiometer. So let's start the code and see the metronome working. As you can see here, I have used an LCD screen to show the beats per minute. Now it's 40 beats per minute. And the tempo, which is largo. These tempos are also visible on this common metronome. And I have also used this convention: largo, adagio, andante, moderato, allegro, and presto for different intervals of BPM. Now, using this rotation encoder, let's increase the beats per minute a little bit. For example, now it's 95 BPM and andante. As you can see, it can also increase by small intervals like 1 BPM. Now, let's go to the, and this is 200 presto. The metronome also has different functionalities, like changing the pitch of the beats. This is the high pitch mode. If we want to switch to the low pitch mode, we switch off these two switches. Now it's in the low pitch mode. The metronome also has an alternating functionality. If we make this switch on and the second switch off, the sound becomes like this, two alternating frequencies. And if we switch this off and switch the second switch on, then the alternating frequencies become a bit higher. The benefit of this behavior is that musicians sometimes want to put an accent on particular notes, and this helps. Another functionality is using this fourth switch. If I switch it on, then as you can see on the LCD, the metronome becomes quiet and passes to the sleeping mode. And I have also used a sound sensor in this project. And now if I clap my hands 3 times, it will imitate the speed of my claps and start the metronome. As you can see, the LED and the sound shows the speed of the tempo, speed of the metronome. Now, if we want to switch back to the normal mode, where we can adjust the tempo by turning this rotation encoder, we just switch the fourth switch off again And now, as you can see on the LCD, we're back to the normal mode, and we can freely adjust the tempo by turning this knob. And still, we can adjust the frequency. Now, let's pass back to the sleeping mode. As you can see, it's sleeping. And now, let's try the sound sensor again, maybe with a faster clap. As you can see, it's imitating the speed of my claps correctly. Now let's switch back to the normal mode. Yes, again, the tempo is according to the position of this knob. The peripheral components that I used in this project are the speakers, the LCD to display the beats and the tempo, the LED to be useful to potentially deaf musicians, the switches, the rotation sensor, which outputs an analog voltage value between 0 and 3.3 volts, which must be converted to a digital value. From this digital value, I use a formula to calculate the beats per minute that this rotation angle corresponds to. And each time the analog to digital conversion is finished, an interrupt is triggered. When the interrupt is triggered, the BPM sent to the speakers is adjusted and the LCD screen is updated. To be able to generate different BPMs and different frequencies, I generated PWM waves from TPM timers. And this is my code. I also used the delay function, and I have used 5 interrupts, one for the analog to digital conversion, 2 for the frequency adjusting switches, 1 for the sleeping mode switch, and 1 for the sound sensor. I have made it so that the switches have higher priority than the ADC interrupt. So I have designed a precise metronome that's ready to be used in the real world. Finally, let's see me practice with 98 BPM.